Identify the key features, then graph. The first thing that I want to do is identify the A value, the B value, and the C value. Now let's get the concavity. The concavity is determined by the A value. If it's negative, it's concave down. If it's positive, it's concave up. Here we have a -2, so we're going to write concave down. Now for the y-intercept, if we have the function in standard form, the quadratic function, the y-intercept is determined by the coordinate 0, c. The c value is -4, so my y-intercept is 0, -4. To get the x-intercept, I'm going to use the quadratic formula. Here is the quadratic formula, and now I'm going to substitute the given values. So I get that x is equal to negative, and b is positive 12. So I'm going to record 12 plus or minus the square root of b squared. B is 12, so I get 12 to the second power. We're going to subtract 4 multiplied with a and multiplied with c. A is -2, c is -4. So I'm going to record a -2 and -4. This is all underneath the square root, and then I'm going to divide all of this by 2 multiplied with a. Reminder that a is -2. So I'm going to put -2. We're going to continue the simplification. So now I'm left with x equal to -12 plus or minus the square root of 144. 12 squared is 12 times 12. That gives me 144. And now I am going to multiply these three quantities. So -4 times -2 is positive 8. But if I multiply -4, I'm left with -32. And then I am going to multiply 2 times -2 on the denominator, and that's going to leave me with a -4. If I continue the simplification, now I get that x is equal to -12 plus or minus the square root, and 144 minus 32, that's going to leave me with 112. And on the denominator, I'm going to get, well, I still have -4. Now, 112 is not a perfect square, so I'm going to get the prime factorization and then simplify the radical expression. So I know that 4 divides 112 28 times, so 4 times 28. 4 is a perfect square, so I'm going to circle that. 28 is the same thing as 4 times 7, and 4 is a perfect square. 7 is a prime number. So now I'm going to get the perfect squares. The square root of 4 is 2, and the square root of 4 is 2. So outside of the square root, I'm going to have 2 times 2, and inside of the square root, I'm going to have the 7. So now this simplifies to -12 plus or minus 2 times 2 root 7 all over -4. And simplifying this again, I'm going to get -12 plus or minus 4 root 7 over -4. Now, I am aware that we're going to have to graph this, and we want the decimal approximations, but I'm still going to go ahead and simplify this to its exact form. So 12 and 4, the greatest common factor is 4. So we get -3 plus or minus root 7. This is 1 root 7. And then we get -4. And then 4 over 4, that's just 1. So this 4 becomes 1, that 4 becomes 1. And we get that the exact solution is -3 plus or minus root 7 all over -1. Now, for purposes of the graph, I am going to get the decimal approximations. So I get -3 plus root 7 all over -1, and -3 minus root 7 all over -1. And with the help of a calculator, I get that the first one is going to give me about 0.4, and the second one should give me about 5.6. Let's continue now with the axis of symmetry. And to get the axis of symmetry, we got to calculate -b divided by 2a. So here we're going to get b is positive 12. So we're going to put 12 over 2 times a. Well, a is -2. Now simplifying this, we get negative 12 all over, and then 2 multiplied with negative 2 is negative 4. And negative 12 divided by negative 4 is going to give me a positive 3. So the axis of symmetry is going to be the line x equal to 3. To get the vertex, we're going to plug in the axis of symmetry. So we're going to evaluate f of 3. And everywhere we see x, we're going to replace it with a 3. And then we're going to evaluate. So we get negative 2 multiplied by 3 squared plus 12 times 3. And then we're going to subtract 4. I'm going to evaluate this from left to right. So here we get 3 to the second power. So we get negative 2 times 9, because 3 squared is 3 times 3. We're going to add this with 12 times 3, which is 36. Then we're going to subtract 4. Here we have negative 2 times 9. That's going to be negative 18. And then 36 minus 4, that is 32. And finally, we get negative 18 plus 32, and that is going to give us 14. So we get that f of 3 is 14. And to write this as the vertex, we're going to write it as the coordinate 3, 14. The axis of symmetry paired with the outcome. So we get 3, 14 as the vertex. Now, if we have a parabola that is concave down, notice that we're going to have a maximum. So the vertex is going to be the max. Now that we have all of the key features, we are ready to graph. And in order to graph this function, I'm first going to make note of the vertex. Notice that my vertex goes up to 14. So I have to make sure that I have 14 units available to graph the vertex. I'm going to count down all the way down to 15. I'm actually going to go down to 16 just to ensure that I'm going to hit that 14. And I've already done this. And also, another thing you have to keep in mind is that your y-intercept also needs to fit. So by doing this split, you can see that the negative 4 is also going to get plotted inside of this grid. So let's go ahead and begin to plot these key features, beginning with the vertex at 3, 14. So I'm going to go to the right 3 units, and I'm going to go up 14 units and make my first plot here, my first point, which is going to be in red. And now I'm going to draw the axis of symmetry. So I'm going to do that in blue. The axis of symmetry is going to cut through the vertex. That's going to be the line x equal to 3. So doing that is going to help us reflect the y-intercept in a few moments. And now that I have the axis of symmetry, I am now going to plot the y-intercept 0, negative 4. So at the origin, I'm going to go down 4 units. And now notice that my y-intercept is 1, 2, 3 distances away from the axis of symmetry. So I'm going to go over 3 distances, 1, 2, 3. And we land on the coordinate 6, negative 4. And finally, I'm going to go ahead and use my best judgment to approximate the x-intercept. So 0.4 is going to be somewhere here, a little bit less than half. And then 5.6, so 5.5 somewhere here, 5.6 somewhere here on the right. And now I have all of the key features. I'm going to connect these with a curve. This is going to provide a sketch of the parabola.